Black hole formation, where gravity's pull bends the fabric of space, creating cosmic mysteries. Hello everyone, I'm your host Dalvinder Kaur from Lovely Professional University. Get ready to dive into today's topic, that is black hole formation. Before we proceed further, allow me to introduce the experts of the day. Dr. S.T. Pathak, Associate Professor, Department of Physics, School of Chemical Engineering and Physical Sciences, LPU, having conducted groundbreaking research at the Institute of Theoretical Physics, Shandong University, China, with a PhD in dark energy and dark matter. So now I would like to introduce the admission nominee also in this webinar, Dr. Lavleen Kumar Bhagi, Associate Professor in the field of Mechanical Engineering. With over 20 years of teaching experience, his vast knowledge and expertise will surely pave the path for attendance, offering valuable information on a wide range of research opportunities, internships, and study abroad programs in the field of sciences. Before we proceed further in today's session, I would like to request everyone, for any questions you can write in the chat box or in the Q&A box, and same will be addressed from my side in the end of this webinar. And now I hand over the things to Dr. S.T. Pathak, and it would be an absolute delight to listen from him. Over to you, sir.
So, thank you so much. So, screen is visible?
Screen is visible. You can continue, Dr. Pathak.
Okay, thank you. Thank you so much. So, black hole formations. So, black hole basically astrophysical object. It's not changing the PPT. What's wrong with this? It's not changed.
Yes, sir.
It's
Yes,
fine.
you can continue.
So, black hole. So the very simple introductions, basic things. So in 10+2, all of you know very well about the escape velocity. So in the classical physics and the classical theory, so what is the escape velocity? Escape velocity is the maximum possible velocity of a particle. When you throw with that velocity, the particle will never come back to the celestial object. So in the case of our Earth, it numerically comes out 11.2 kilometer per second. So in the mathematical form, it can be given as V square is equal to 2gm over R. So where R is the spatial radius of a celestial object and m is the mass, right? So what happens if this escape velocity becomes the speed of the light or exceeding the speed of the light? So technically, the things never come back to never leave the surface of the celestial object, right? So suppose 11.2 kilometer per second exceed to the speed of the light or more than the speed of the light. So even light cannot escape from this Earth, right? So that particular radius up to which the escape velocity becomes the speed of the light or more than the speed of the light, then the things will be very interesting and exotic. It's called the black hole technically. So historically, it was the first time John Michel put the questions: what happens if the escape velocity more than the speed of the light? And the answer given by the different scholar in those days. So Laplace in the 1796 studied these object in the classical theory or the classical physics. So in fact, to understand what happens exactly the extremely heavy object, how to speed, how the object that cannot be the surface of the any celestial object, that will be the part of the special Einstein theory of relativity. And Einstein theory of relativity, basically the theory of gravity by inclusion of the special relativity. So once you incorporate the special relativity with the Newtonian gravity, and that theory is called the general theory of relativity, right? So look this picture. In the classical theory or the classical physics, how the classical physics encounter the black hole. So right hand side in this panel, you can see its escape velocity increasing and increasing and increasing. And finally, the particle are the things that cannot be escaped from the surface. And this is the black hole, but it is the wrong. So the result is there accidentally correct, but the derivation is wrong. So this mathematical derivation is not perfect. This derivation can be incorporated from the general theory of relativity. Later we will see. So this mathematical expression is not new for you. You already encountered in the 10+2 classes and grad courses also, the Newtonian gravity and the Kepler's law. So look here, what exactly happens. Suppose the mass very high, fixed mass, and the radius very high, then the things will be in the gaseous form, right? But the mass will be the constant and radius will be decreases. So rock medium gravity, this is the medium gravity just like the Earth. But in the case of the Jupiter, the radius is very high and the things will be in the form, not form of the solid, right? That will be in the form of the gases. So gaseous giant, Jupiter and the Saturn. And you can see here, the person just settle down on the surface and very high gravity. And the very high gravity, and that means radius becomes the 2 gm upon c square. In particular, this is the technical terms. This radius is called the Schwarzschild radius. And later we will see how the Schwarzschild radius will work out. That is the solution of the Einstein field equation. So this is basically the black hole. So what is it? What is this? Black hole, basically the region of the space-time from where nothing is comes out. Nothing is comes out from the region of the space-time is called the black hole. And you can calculate if the average star, which mass is equal to the mass of the sun, and you can technically calculate, right? Mathematical calculation, straightforward calculations, what the value of radius will comes out. So substitute the mass of the sun here, 2 times of the 10 to the about 30 kg, and the rest of the constant value, and the radius will comes out 3 to 4 kilometers. So in the hypothetical situation, our sun just started to collapse and become the radius of the 3 or 4 kilometers, 3 kilometers or 3.5 kilometers, and the mass becomes constant. Then the light, even light cannot escape from that particular surface, and that is called the event horizon, right? So event horizon is the technical term. And look here, this is the beautiful picture. In the normal star, the light can escape from the surface, right? This arrow you can see. And the neutron star, another astrophysical object, we will see its core will be populated by the highly degenerate neutron gas. So light started to bend because the space-time just take the curvature near this massive object. And the massive neutron star, you can see the light is just bended, but in fact the light is just leave the surface, right? But in the case of the black hole, even light cannot leave the surface, right? So the things will be merged inside, and this is the case of the black hole. So further going to the formation of the black hole, so it is a appropriate way how to study the star formation or the structure formation. So how star will be formed, right? So once you know how the star will be formed, then you will understand how the black hole or how the white dwarf and the neutron star will be formed. So the formation of the structure or the star formation that will be understood by the Jeans instability in our graduate course. The Jeans instability in the astrophysics is a part of our syllabus. So gravitational collapse means the interstellar medium started to the collapse by the self-gravity, right? So due to the fluctuation, contractions of the almost stationary interstellar medium, they start to the collapse. And what happens? The mass that will be calculated from the Jeans instability theory. So this mass can be represented by the mj, and which is the function of the temperature, right? So right hand side, you can see here, it is the 5 times of the Boltzmann constant. Here the T, the temperature, and the rest of the term is known, very well-known things, and rho is the density. So the mass of the cloud or the mass of the interstellar medium sometimes just increase this particular mass called the Jeans mass, then the collapse will be started, right? But if the mass of the cloud or interstellar medium somehow is less than the mass of the Jeans or Jeans mass, then collapse will be not started. So the Jeans mass is the boundary line or the mass criteria on which the collapse will be started. So what exactly happens? This collapse will be the 2 types. One is the adiabatic collapse and another is the isothermal collapse. So isothermal process, you know, it's very well. in the thermodynamics. The isothermal process in which the temperature becomes constant, right? And the adiabatic process, the process, thermodynamic process in which the transfer of the heat is not possible. And technically, the change in the heat becomes zero. That is called the adiabatic process. So isothermal gravitational collapse, or it is say the gravitational free fall. So what exactly happens? Since in the beginning, the optically thin cloud, right, not very dense. So in this sense, the energy generated to the collapse that will be leave the surface that can be easily pass out. Therefore, the temperature not change, and this process is called the isothermal collapse. And you can calculate it. It will be comes out 10 to the power 5 years for the molecular cloud. And molecular cloud are the interstellar medium, mostly dominated by the neutral hydrogen. And when they are started to collapse, then it will be comes out 10 to the power 5 years. It's called the free fall. And another technical terms appears, especially in the structure formation, mainly star formation and galaxy formation, is called the fragmentations. And what is the fragmentations? So fragmentation means, suppose just imagine a situation in which the ice started to melt, right? So suppose a pond, due to the cold, all the pond just freeze out, and due to the high temperature, just temperature rises, then it is started to melt. So all the ice not at the quickly at the particular time that will be melt together, right? There will be the some small patches. So small patches first melt and they become the water, and the some small patches become the solidified. So same things happens if the big cloud or interstellar medium, they started to the collapse, but there will be the small pieces, small patches, they will collapse very fast, right? As you can see, R is equal to 0, the cloud will start to the collapse and density will be increases. And ultimately, this condition, the Jeans mass conditions hold and collapse started, then the small patches, right, that will be collapsed first in comparison to the overall interstellar medium started to collapse. So this is called the fragmentations, right? So one giant cloud undergoing to the monolithic collapse, the cloud fragmentation into pieces. This is called the fragmentation. It is a very important. Next is the adiabatic collapse. And I just mentioned the isothermal collapse and the adiabatic collapse. So adiabatic collapse, when the fragmentation occurs, then therefore the opacity just changes, right? And the density will be rise. So due to the high density, the heat created or heat generated in the process of the gravitational collapse that will be not easily go beyond, not pass to the gravitational core. And that means the dq becomes 0, and this process is called the adiabatic process, or this type of the collapse is called the adiabatic collapse. So according to ideal gas equation, as we know, so the temperature means higher pressure, higher temperature means higher pressure, pressure becomes higher, and star free collapse of star, all the phase collapse of the star. And finally, due to the gravitational energy, and it becomes the black body radiations, and radiation will be comes out. So very important question here just appears. So at what mass does this happens? So gravitation collapse is started, but a particular mass when it will halt, right? So this can be calculated. The mass just equal to the average star mass, that is the particular mass of the sun. That means collapse just halt, and the fragmentation. So once the protostar will be formed, but gravitation collapse will be not start, right? So interstellar medium, you can know here how the interstellar gravitation collapse just give the birth of the protostar, right? So interstellar cloud of the gas remains in the hydrostatic equilibrium. Hydrostatic equilibrium means pressure, internal pressure or thermal pressure, they just count further gravitational collapse, and system will be virialized. So it is just like the things push inward, and the inward things push outward. So if the inward pressure or outward pressure both will be the balance, then things will be stable, right? This stable is called, the stability is called the hydrostatic equilibrium, and it is a very important step, especially in the star formations, right? So this condition is called the virial condition, and in technically this theorem is called the virial theorem, in which the potential energy that which is equal to twice translate the internal thermal energy, right? So once the system will be virialized, once the system will be hydrostatic equilibrium, that means the star will be the form, right? So this is the all of the star formation. In this picture, you can see here planetary nebula, right? And here star forming nebula. So star forming nebula is proto-star just form, and star mass is just like the mass of our star or average star. So at the radiation, when the radiation pressure becomes less than the gravitational pull, so due to the gravitational collapse, it will be fate of this star, and after the billion years, it will become the red giants, and after the red giants, it stays the planetary nebula, and first the radiation pressure tried to balance the gravitational collapse, gravitational pull. But if the radiation pressure not sufficient to counter the gravitational collapse, the system will be further continuously collapsing. Then the quantum degeneracy pressure will comes out, and core will be populated by the electron gas or fermionic particle, especially the fermionic particle populated by the electron, not the neutron. Then it will become the white dwarf. So in nutshell, you can say if the mass of the star is less than the Chandrasekhar limit, which is equal to 1.39 times of the mass of the sun, so the future of the star or the death of the star in the form of the white dwarf. But what happens if the very huge, very massive star will be formed from this star formation nebula? Nebula is the star nursery where the star are just formed. So this massive star, the collapse will be the same, becomes a red supergiant, and due to the red supergiant, gravitational collapse, when the radiation pressure not sufficiently to balance the self-gravitational collapse, the star will be exploded, and that is explosion is called the supernova. And the supernova is a very important. So in this universe, after each 10 seconds, somewhere the supernova occurs. So after this supernova, there will be the shock wave will be created. That shock wave create the further nuclear fusion process, and the heavy metals will be formed. So supernova is a very important step, or very important for the evolution of the universe and the structure formations. So I will come on the later how the supernova will form. So if the star, this star will be the mass will be the very high, and just like the white dwarf, the core will be populated by the neutron. In fact, the proton eat the electron, and the neutron density will be increased more and more, and the core will be populated by the neutron particle, this fermionic particle, right? And the quantum degeneracy pressure further stop the gravitational collapse, and this star becomes a neutron star, right? Sometimes called the pulsars also. And but if the mass will be much more than the limit is called the Tolman-Oppenheimer-Volkoff limit, and here this mass limit is called the Chandrasekhar limit. So this will become the black hole. So I will concentrate on here how the black hole will form, not on the neutron star and the white dwarf. So you can see here the 3 steps: either neutron star, black hole, or white dwarf. So in the next slide, you can look here this picture. In this picture is a little bit clear here. Star nebula, where the star will be the form. Nebula means where the star formation occurs, and this star nebula basically dominated by the neutral hydrogen gas or interstellar medium. So average star means the star just like our sun. And what happens if the virial theorem is just violated? Virial theorem is not whole good, and in this case will become the red giant and the planetary nebula, and finally the white dwarf, right? Otherwise, the second scenario, if the mass of the star much more than our mass of the sun, then it's called the massive star, and it's like the red supergiant, not like the red giant. And sudden, if the pressure sufficiently hold the gravitational pull or gravitational collapse, then it will be exploded and converted into supernova. And after the supernova, it will become either highly pulsating star, rotating star is called the neutron star, or in the black hole. So these are the simple, not very technical, because we just avoid the mathematical calculations and all of the general relativistic concept. So simple physical theory. And as you can see here, what exactly average star? So average star, it is written. I think you can read it very clearly after the achieving the equilibrium. Equilibrium means here the hydrostatic equilibrium, right? So gravitational pull, something is like that. Gravitational pull inward direction and the radiation pressure and the radiation force outward directions. So once these two forces will be equal, then the system will be virialized, and they call the virial condition, right? So our sun in the virial condition, our sun in the hydrostatic equilibrium, right? And the red giant, and it will be form the white dwarf, black hole, or neutron stars. So the mass limit that will be decide the star will be formed after the death white dwarf or neutron star is called the Chandrasekhar limit, and the neutron star and the black hole, that will the Tolman Volkoff, Oppenheimer Tolman Volkoff mass limit. So another chances, this is called the black dwarf. So white dwarf further converted into the black dwarf, that will be nothing is from south, and just like the neutron star in the next theory, you can see how the neutron star just go through. So here the technical term in the stellar remnants, right? The stellar remnants either in the form of the white dwarf or black hole or the neutron star. So as you can see, depending on the mass in the board letter, I'm just right here, depending on the mass of the star, they are formed from the planetary nebula, and its lifetime that will be converted into three stages, either white dwarf or neutron star in black hole. So white dwarf are the astrophysical object which core dominated by the degenerate electron gas. What the means of the degeneracy? Here degeneracy means the classical pressure that will be not sufficient to balance the gravitational collapse, and due to the quantum mechanical effect, as you know, the fermions, they follow the Pauli exclusion principle. That means the two fermions cannot be lived together in the same spin state, and they create the quantum degeneracy pressure, and this quantum degeneracy pressure again started to stop the gravitational collapse, and that will be converted into the white dwarf. But in the second case, if the star mass will be the much more than the Chandrasekhar limit, or the more than the average star, then the proton or electron that will be combined together and neutron will be the left. So in the theory of the beta decay process, you know very well, neutron converted into the proton and proton converted into the neutron, and therefore the beta particle and anti-beta particle is called the positron decay. Positron will comes out. Positron will comes out means the proton converted into the electron, and the positron will be the form. But in the opposite process, neutron converted into the proton with the electron will be formed, and then anti-neutrino will comes out, right? So therefore, the neutron will be populated the core, right? And this type of the star is called the neutron star. So gravity is opposed by the electron degeneracy pressure in the case of the white dwarf, and that this degeneracy pressure will balance the gravitation collapse. And the Chandrasekhar, who developed the theory, mathematical theory, and the very nice book written by him, the mathematical theory of the black hole. So if you have time, then read that book, in which you can understand the complete mathematical theory. So this mass is clear to you, 1.39 times of the mass of the sun. That is a limit for the white dwarf and the neutron star. And next is the supernova. What is the supernova? Supernova means sudden the pressure of the radiation just not sufficient to balance the further gravitational collapse. So within the second, the star will be exploded very high. This phenomena, this stage is called the supernova. And there are the different types of the supernova, and another type of the supernova is type 1a that will be occurs in the binary system. So one white dwarf star just rotating about the center, common center of mass, and the another star. So the another big star, they try to eat the white dwarf, and the white this will be end up with the very big explosion, and this is called the type of supernova. So type 1 is supernova, type 2 is supernova. So different type of supernova. Neutron star will be formed after the type 2 supernova. And the type 2 supernova, that means the star have the least 8 times of the mass of the star, right? And that will be undergoes the explosion. After the supernova explosion, it will be converted into the neutron star, not in the white star. So remember this density and the density electron star which comes out up to the order 10 to the power 17 kg per meter. See, of course, it is the very high density. Mass will be lies from 1.4 to the 3 times of the mass of the average star, and of the mass of the average star that will be converted to white dwarf. Otherwise, it will be converted into the neutron star. So I was talking about this limit, TOV limit, Tolman-Oppenheimer-Volkoff limit, and this is the upper limit that will be leads to the collapsing star will be converted into the neutron star or in the black hole. So if the mass of the neutron star, which is this TOV limit or more denser, that will be converted into the black hole, right? So the theory tells us you cannot avoid, you have not a sufficient reason to stop the what happens next if the gravitational collapse much more than the quantum degeneracy pressure of the case of the neutron star. And then there will be the theoretically possible the star will be form of the quark star, because the quarks are the fundamental building blocks of the baryons, and there are the 6 family of the quarks, 6 number of the quark and the 6 number of the antiquarks, right? So particle physics suggests the nucleons, especially neutrons, they are just made by the 3 quarks, down, down, and up quarks, DDU, and the proton just made by the UUD, up, up, and down quarks. They have the fractional charge, and the charge quantization just fail on the quark, right? So that will be the different part. So let me come back. The star will be further either in the form of the quark star or the preon star. That will be the possible, right? Neutron star further converted in this form, and this will be indistinguishable because we don't know nothing about the what core inside the neutron star. We have the very less knowledge about the core of the neutron star. So this means the exotic matter in the form of the pure quark and the preons, that will be lies in the crust of the ordinary degenerate neutron star. So it is the branch of the further investigation, further research in the neutron star. The theoreticians, they are working on this. Okay, so this picture depict the main stages of the neutron star and a very quick time. How much time do we have? Okay, so 10 minutes more. So you can see the inner core massive star, which mass is the much more than the Chandrasekhar limit, and inner core, I was talking about the hydrodynamic equilibrium, and this arrow, black arrow is showing the gravitational collapse, and inside the radiation pressure that will be counter the further gravitational collapse. And then in this stage, you can see here the streaming of the neutrino. As I'm talking about, the proton converted into the neutron. In this sense, the positron will comes out with the neutrino, and another process, neutron converted into the proton, then electron will comes out with the antineutrino. So there is the streaming of the neutrino from the core, and once the neutrino will be detected, then we can know what physics runs inside the core of the neutron star. That will be the further subject of the study. So you can see here the supernova explosion, and after the supernova explosion, the stable structure will be formed. This stable structure, highly dense and the rotating, right, in the pulsating star, is called the neutron star. So stellar remnant state, and let me come back to the black hole. So the black hole is predicted by the Einstein theory of relativity, which is nothing but a special theory of relativity merged together the Newtonian gravity, right? So Newtonian gravity with the special relativity lead to the general relativity. So in the general relativity, black hole predicted by the Einstein, and the boundary where the nothing is escape out is called the event horizon, right? So event horizon means it's the very technical term, a boundary of the space-time from which the nothing is comes out, right? The things will be comes inside, but nothing is comes out outside, even nothing, any information, not light. It's called the event horizon, and which radius is comes out r is equal to 2 upon c square. So at the center of the black hole, that is the one kind of the singularity. So you can see here the gravitational singularity. This singularity is called the gravitational singularity, and where the law of the physics is just fell down. Nothing the law of the physics will hold. And this type of the situation is a very dangerous for the theory, and any good theory that will be the free from the singularity. All right, and photon sphere. In the case of the black hole formation, this is the another technical term is called the photon sphere. And what is the photon sphere? It is basically a spherical boundary of the almost very less thickness or almost the zero thickness. And from his, the photons that move in the tangential direction, right? Not inward, that is the outward. And this type of the circular orbit, this type of the circular patch is called the photon sphere. And for the non-rotating black hole, the photon sphere, almost the radius are 1.5 times of the 2 gm upon c square. 2 gm upon c square is called the Schwarzschild radius. So event horizon telescope, this take the picture, and in those days, media take the attention about the black hole picture, just confirm, and Einstein general theory of relativity supported by these observations. So all of you know it. And black hole features and theory. So once the black hole will form, then the different theoretical model, the theoretical model for the black hole, just started. The different person, different researcher, they give the theory, right? So the gravitational field near the gravitational black hole or the astrophysical black hole, the gravitational field will be very high, and due to the strong gravitational field, the curvature will be very high near to the surface. So there is a misconception. The black hole just eat everything, thus just sucking everything. This is the completely wrong perception about the black hole, right? So when you are approaching toward the black hole, there will be the tearing of the things, just like the tidal force. So on a one single body, there will be the multiple gravitational force occurs, more than the one gravitational force occurs, that the things will be just tear up, right? So the same things happens in the case of the black hole. The things will be just orbiting and indefinitely without getting the any closure. So this is the very wrong perceptions, and the strength property of the space time, that means the black hole, it will be singularity will be the form. And something about the event horizon. Event horizon first time given by the Stephen Hawking, especially in the development of the theory of the cosmological black hole, or in the digital expansion. So event horizon, the boundary of the space-time from where nothing is comes out or nothing can be escaped, is called the event horizon. So according to general theory of relativity, because the relativistic theory of the black hole in the general theory of relativity, any black hole that can be characterized, that can be understood by the only the three parameter, not the four parameter. All of these three parameter and electric charge. So mass, angular momentum, electric charge, only these three parameters be available for the study of the black hole. So John Wheeler, first time they just gave the no hair theorem. The theorem name of the theorem is called the no hair theorem. Black hole have the no hair. The black hole, only the three parameters that can be provide the information about the black hole. And these all three parameters, mass, angular electric charge, right? So this is called the no hair theorem. And what is the singularity? Singularity is the technical stage where all the space-time becomes the infinite curvature, infinite gravity, where the law of the physics just fell down. And the singularity is the very dangerous for the theoretical physics or the any theory, right? So it is expected to generalization of the GR, especially in the quantum gravity, that will be the change. What is the thought about the nature of the black hole interior? So quantum gravity tried to find out the answer, what exactly happens, what the physics runs inside the event horizon. But some of the theoreticians interpreted the mathematical singularity with the equation indicating that the current theory that is not incomplete. So some theoreticians, they are just claiming that we have the theory, we have no any complete theory to understand inside the black hole or inside the event horizon. So this is the one reason why we are not able to do it. So we have to first develop the complete theory, then we will be able to understand what inside the event horizon. And the cosmic censorship hypothesis, the cosmic censorship hypothesis means, in this hypothesis, the singularity that will be hidden inside the event horizon, right? So nothing is comes out from the event horizon. Therefore, this singularity is just hidden, right? It's a no net singularity. And this hypothesis, although this is the hypothesis not verified from the observations. So hypothesis 2 remains the active area of the theoretical physics. So in the theory, the censorship the hypothesis, there's a cosmic censorship, the researcher working on this hypothesis. And rotating black hole, some physicists and cosmologists, they suggest, astrophysicists suggest, the black should be rotated. So if black hole will rotate, then they have some angular momentum. And due to the angular momentum, the drag of the space-time near the event horizon. And this effect is called the frame dragging. Remember this effect. Frame dragging means the rotation of the black hole. And due to the rotation, there will be some drag of the space-time near the event horizon, right? And this means spinning areas around the event horizon called the ergosphere and then ellipsoidal shape. Ergosphere and then it will become the ellipsoidal shape. This is because of the rotation incorporated in the black hole theory. So in the theoretical development of the black hole, so that will be given by the Stephen Hawking and the Jacob Bekenstein. So they just give the conjecture, black hole conjecture, and follow the second law of the thermodynamics. So gravity or entropy that will be proportional to the area. So the third point, Jacob Bekenstein with the Israeli scientists, theoreticians, black holes should have the entropy, and that entropy is proportional to A by 4. A, where A is the horizon area, right? So second law of the thermodynamics, violation of the second law of the thermodynamics here, the any material just entering inside the black hole, then that will be the disappear. And when it will be disappear, that means the total entropy of the universe should be decreases. So this is the second law of the thermodynamics, and therefore motivated from the second law of the thermodynamics, Jacob Bekenstein and Hawking just give the conjecture. So entropy that will be depend on the horizon area. So classically, the black hole do not emit any radiation according to thermodynamics, classical thermodynamics. But Hawking used the quantum mechanical effect and suggest and develop the mathematical theory, the black hole should radiate radiations or thermal radiation. Finally, it will be evaporated. And that radiation in the form of the Hawking radiations, right? So first law of the thermodynamics, it follow the entropy of the black hole in the 1/4 of the area or area by the 4. And they extended after applied the cosmological horizon, such as in the de Sitter space. De Sitter space means the space for the exponential expansion. Even they have the no mass, right? That's a different cosmological theory. I will come later. And holographic principle, now that is a very hot topic in the cosmology, the people's working on the holographic principle. And the holographic principle means it is the based on this one, the maximum entropic object. So black hole is basically the maximum entropy object. That means the maximum entropy of a region of the space-time or entropy is the largest black hole, and it is correct for the holographic principle or holographic or as graphic dark energy different model. So what the Hawking radiation means the radiation that is reduce the mass of fluctuation in the field, particles and antiparticles will be created. And the one is just merge inside the black hole, and the rest part and the another part is just fly away outside. And this radiation is called the Hawking radiations. So, and another is called the information loss paradox. Sometimes its name is the black hole unitarity. This is the again a theoretical model on which the people's working, including the Leonard Susskind. They're also working on the information loss paradox or black hole unitarity paradox. So next, this one you can see this the in the pictorial form what exactly happens near the black hole boundary. So in this red color cylinder, you can see this boundary is the boundary of the event horizon, and due to the strong gravity, the light cone becomes tilted, right? So due to the light cone becomes tilted, so suppose the any observer here, so the light cone of the observer or word line of the observer that will be not intersecting the line of the light that comes out from the this horizon or this boundary, they will be going to the parallel, then that means they will be not intact. So this is the simple mechanism. So near the black hole, due to the strong gravity, the light cone will be tilted. So as you can see, this green color line is inwards the light, and this blue color is just going outside, right? So in the caption, it will be the given. The horizon is a cylindrical separate. The two types of the ray. Those represented the blue lines. Blue lines mean that escape the black hole, and dotted lines that trap the inside. The dotted line is the trap inside the event horizon. And green lines, that means in falling light rays inside and cross the horizon without the any hindrance, right? So this is a beautiful picture taken from the Roser Penrose work. And mathematical theory, yes, it will be a little bit difficult for you. And this equation, first one is called the Einstein field equation with the cosmological constant. In the left-hand side, the cosmological constant here, Ti is the energy momentum tensor. And solve this field equation. And this line element is called the Schwarzschild line element. My student, Devnarayan Bajikuma, right now he's at Heidelberg University. So in the year 2022, he published the paper. They solved the Einstein field equation in the Schwarzschild matrix, and by the choice of the different kind of the function. The choice of the different kind of the function that will be independently. The solution will be same if you choose any kind of the function. The detail are the available. Now this paper is open access, so anyone can visit the JHEP and access the paper. Anyway, so the solving this equation with this line element, and the one object, just like the Earth, Schwarzschild radius is comes out 9 millimeter. So you can see if our Earth, the mass will be not changed, and somehow the Earth will be just squeeze smaller and smaller object, and it become the 9 millimeter size. Then that size is called the black hole. Although it is theoretically not possible, but just imagine this will be from the black hole, and this 9 millimeter, about the size of the marble, is called the event horizon. And the mean density inside the Schwarzschild radius, it will becomes out numerically. You can find out what this value, substituting the mass and the rest of the constant term, and you can find out. So on the basis of the no here theorem, how many the things, the parameters here, charge and rotations, right? The charge and rotations, there were the four types of the black hole. Uncharged, if the no charge and no rotation, so that type of the word black hole appears in the Schwarzschild solutions, right? There will be the no angular momentum, no charge. No charge, but finite angular momentum that the black hole started to rotate, that will be available in the Kerr metric, and the Kerr solutions is a rotating black hole uncharged. And if you consider the charge and no rotation, so regional Nordstrom black hole, in the regional Nordstrom metric, this type of the black hole is available. And the Kerr-Newman, you will consider the rotation as well as charge. So the four types of the solution, four types of the black hole in the theory, they are just developed. And they are the alternative model of the black hole, apart from the main general theory of relativity. There are the alternative model theoreticians, but in the media, they are just taking it seriously, especially this one, the dark energy stars, right? In the 2005, George Chaplin in the Lawrence lab, they developed this theory. The black hole is nothing. It is basically made by the dark energy star. So it was the popular in the media, but not in the theory, not from the scientific community. And another alternative theory, the black hole, what about the singularity? No singularity, continuously collapsing object. Abhas Mitra were working the Hubble Atomic Research Center. They are proposing the black hole is a continuously collapsing object. There will be no any singularity. Another theoreticians, they are working on the gravitar. So prominent alternative theory of the black hole is called the gravitar, right? And they are the different theory. And the last one, you are know about the what is the wormhole. Wormhole is the again just like the black hole. Wormhole is until now not confirmed by the observation, and wormhole is predicted in the general theory of relativity by the Einstein. So it is the shortcut in the space-time structure, or it is believed the link between the two black hole or tunnel between the two black hole is called the wormhole. So wormhole is the solution of the field equation, Einstein field equation in the general relativity. And you can just look at this analogy, the point A and B. When the sheet of the paper, they will be just folded, and how the ant can move from the to B. So there will be the shortcut, just drop from the point A to B, and this is called the wormhole. And finally, just to conclude it, and the last, the story never ends, even not begin. So don't stop thinking, don't stop asking the questions, right? So keep thinking, and see you soon in the classroom, right? So thank you so much.
Thank you so much, Dr.
So
Pathak. Thank you so much.
yeah,
So it was
yeah,
wonderful,
please.
delightful discuss on effects of gravity, effects of black hole on light, star formation, life cycles of sunlight and massive stars, black hole features and theories, and many more. And now I would request to the admission nominee, Dr. Lavleen Kaur Bhagi, to be on the screen. Over to you, sir. Sir, unmute first.
Very good afternoon, ma'am. Very good afternoon, ma'am.
Good afternoon.
And very good afternoon, everyone. First, I would like to thank ma'am for such a wonderful introduction of mine. And I would extend my regards to Dr. Pathak for their insightful presentation. Uh, Now I'm going to discuss about the, you can say, regarding the accreditations and the approvals we have in the LPU. I'm going to share my screen.
Yes, please.
Yes, sir. Share your screen.
So
Yes, sir.
we have,
Screen is visible. You can continue.
yeah, right, ma'am, right.
Thank
Thank you so much. Uh, Very first is we have a National Assessment and Council grade we have, that is called NAC grade, that is A++. And if we talk about this NAC grade, we receive, LPU receive the highest NAC grade, A++, with score of 3.68 on 4-point scale. And what it means, this means it is the highest score in the first cycle of accreditation among all the government and private universities. And NAC basically assess on the following 7 criterias, like curricular aspect, teaching, learning and evaluation, research, innovation and extension, infrastructure and learning resources, student support and progress, governance, leadership and management, institutional value and best practices. So these are the 7 parameters on which a NAC will give the grading. And another accreditation we have for the School of Management. And in this case, Accreditation Council for Business Schools and Programs, that is accredited under this program, School of Business. And it is specialized accreditation association for business education, supporting, celebrating, and rewarding teaching excellence. And then we have approvals, like we have UGC approval, and also we have UGC distance education approval. Means the distance programs we are running is also have the UGC approval. And then we have another approval, that is NCTE. This NCTE approval is basically for the education programs like in a BSc B.Ed, or we can say like B.Ed program, like M.Ed program, that is the education programs. This approval must be there. And then we have Pharmacy Council of India, that is PCI. This approval is required for the pharmacy programs like COA, that is Council of Architecture. This approval is required for the architecture program. And Bar Council of India, that is BCI. This is for the law programs. All India Council for Technical Education, OTL, distance as well as learning programs. Institute of Town Planners, that is ITPI. This is for the planning programs like B Planning, Bachelor of Planning. And then we have Indian Association of Physiotherapists. This is for the Bachelor of Physiotherapy programs. And then we have Punjab State Council for Agricultural Education. This is required for the like BSc Agriculture program. And then we have membership of like Association of Indian Universities. We have International Association of Universities and Institute of International Education. If I talk about the placement and the achievements, our student got 3 crore package, and this he's working in Germany, a BTech CSC student. Another student we have got the 64 lakh rupees per annum package. The list is going on. If I talk about the total number of students, that is 431 students selected at the package of 10 lakh to 62.72 lakh rupees per annum from the 2021 to 2022. And furthermore, the list is, as I told you, going on. So that is 54.75 lakh rupees per annum, 49.4 lakh rupees per annum. So these are the you can say placed students, and they are working in a very reputed organizations like Amazon, Palo Alto, Google, like this. And another thing I want to add over here is that LPU breaks the unbelievable record. That is 13 students who have participated in the Grand Tokyo Olympic Games in the year 2020. And we feel proud of the Indian Olympic, that we feel proud that nearly 10% of the Indian Olympic participants were LPU. From the Indian captain hockey team, that is Manpreet Singh, to the you can say Neeraj Chopra, to the wrestler this Bajrang Punia. So out of the 13 students, 12 students create the history: one gold medal, one silver, and 2 bronze medals. And then another winning history in the this National Sports Award, Maulana Abdul Kalam Azad Sports Trophy 2023. Our team is first runner-up, and it is a first ever private university to clinch the title since its inception in 1956. Furthermore, if I talk about our various programs, so under the physical sciences, chemical engineering and physical sciences, if I say total 13 programs we are running, like BTech chemical engineering lateral entry, we have BSc chemistry, we have BSc honors chemistry, BSc mathematics, we have BSc honors mathematics, and physics we have honors physics BSc we have. And then we have MSc, we have MSc in physics, MSc in mathematics, MSc in chemistry. Along with this, we have BTech programs in chemical and physical sciences. Like we have BTech, we have BTech mathematical and computing programs. BTech chemical, I have already been told you. Another program we have MSc statistics and data analysis program we have. And if I go with how you are going to check it out, our website, just give me a second. I'll going to share this our website. Yeah, so this is our website, that is lpu.in. And if you go to the website over here, then go to the about. If you go to the about over here, if you want to explore more about LPU, then you can explore over here. Like if you want to see the ranking of LPU, then you click over here for rankings. Then the like NF ranking we have, World University ranking we have, Impact ranking 2023 ranking update list you can get over here, World University ranking, QoS ranking, like various type of rankings you can get over here. Like if I going to open this NIRF ranking, then you can see the rank of LPU under this ranking, NIRF ranking. So first thing is this. Then if you want to check it out, your interested program in LPU, then you go to the admissions. Then you go to the after 12th undergraduate programs, like regular programs. Regular means We have the various types of various you can say options in LPU. Like if you are interested in the distance learning program, then we have. But uh, there is a restriction over there that only Punjab students we allow. Then there is a online programs we have, and then regular programs we have. Regular program means at least minimum 75% attendance is must, and the classes will be conducted in the campus only, physical mode. So you go to the regular programs, then there is a
Yes.
filter option. Filter option will come.
Okay.
There is a filter option will come like this. That is 12th select discipline. And another discipline, you can see various disciplines over here. Like if you are interested in the physics, you go to the physics, then you select the physics over here, and then you can see BSc Physics and BSc Honors Physics. So two different programs, duration programs we have. One is BSc Physics, another is the Honors in Physics. If you click over here, suppose you click BSc Honors Physics, then you can get to know the relevant details for this particular program, BSc Honors Physics. From the eligibility criteria, like if I talk about the eligibility criteria for BSc Honors Physics, you should have minimum 60% aggregate marks in your 12th class, and you should have studied English, physics, and mathematics in your 12th. Along with this, the LPNest is mandatory. LPNest is our national level test. This is a mandatory. If you don't have the LPNest, then CUET we can consider. And either you qualify LPNest or you have to qualify CUET. Then only you are eligible for this particular program. If I talk about BSc Honors Physics, and then you can check it out the curriculum details. Means curriculum details means in the first semester what subject you are going to study, and in the second semester what subject you are going to study. Likewise, second year, third year, and fourth year. As BSc Honor Physics is having BSc Honor Physics, BSc Honor Chemistry, BSc Honor Mathematics is a 4 years duration program. So accordingly, you can see the uh, subject you are going to study. If you have, suppose you want to go for the specialized programs, then we offer the department electives program subjects also. Like under the this BSc Honor Physics, you go with the classical dynamics or medical physics or quantum mechanics and applications, statistical mechanics. You can go further based as per your interest of the career interest. Like if you are interested to go to the corporate job, then these are the subjects you are going to study. If you go to the government job, then accordingly, if you go to the higher studies, then physics aptitude 1, physics aptitude 2. These subjects you are going to study as per the your career pathways. Furthermore, as I have told you, the BSc Honor Physics is of 4 durations, and in our university, the fee basically depend upon the student caliber. If you good at in the 12th class and you good at LPNest or you good at CUET, then you will get the maximum benefit. Like if you got 95% or more marks in the 12th class, then you get the 40% scholarship benefit. 40% scholarship benefit means as it will the program fee for the BSc Honor Physics without scholarship is 50,000 rupees. But if you got this much marks, then with 40% scholarship, the applicable fee will be 30,000 rupees per semester. If you got the Alpinist category 1 score, then again 40% scholarship benefit you can get. So either 12th class or in the LPS, if you got this marks, then your scholarship will be 40%, and accordingly your program fee will be applicable. Similar way, 3 categories we make 40%, 35%, 30%. So this is the scholarship categories uh, we have, and then accordingly your applicable fee will be there. And furthermore, if you want to know the various what are the other scholarships you can get over here, then on the basis of CUET scholarship, we are giving other scholarships over here. You can have, if you have innovation, you have startup, you have entrepreneurship, then we give the scholarship. If you have the sports activities, you have certificates from the previous 2 years, if you have a cultural certificate, if you have R&D, if you have co-curricular activity, social service, bravery award, then we consider. Then financial aid we give on the basis of if you have a dependent card, defense dependent card, then we consider this also. And furthermore, how to book your seat? That means first you go to the our website and then click on the apply now. If you click on the apply now, then our website admission.lpu.in will open. Over there, you have to first register yourself. That is from your name, email ID, mobile number, state, city, gender, qualification. And if the qualification is 12th class, and then your discipline will come as per your qualification. Then you have to select the discipline and then click on the register now. After registering your mobile number and email, then dashboard will open. And in the dashboard, you have to go to proceed further. Then you have to appear for the LPS, you have to book your slot, and then after qualifying, then you can take to proceed to admission. And the important dates, if I talk about for the month of April, the slot booking is already going on, and the last day to book and apply for LPNest is 30th of April. Today is 26th April, and date of entrance exam for the LPNest exam is being 15th April to 4th of May. And the result of your LPNest exam will display within 48 working hours. And after displaying the result within 7 days after the declaration of the result, the last date will be 5th of May. So that means on or before 5th May, you have to book your seat. And the LPNest we have conducted in both modes. Both mode means remotely proctor. If you are interested to give the LPNest exam from your home, then it is called the remotely proctor home. If you have a proper infrastructure at your home. And if you are interested to go to the test center based exam, then we also have this option. So as per your interest, you can go with you can select the remotely proctor test or test based center based test. And if you want to further contact us, then if you go to go to the website and then contact us is there. You just click over there, and then all the relevant mobile contact number is being available over there. Like if you are general or admission related query, then you can contact any of these numbers. If you want to do the chat on WhatsApp, then this number you can note down. And if you want to mail us, then admissions@lpu.co.in. So these are the contact details. So this is all about the particular program. I hope if anyone is having query, I'm glad to give the reply. Thank you, ma'am.
Thank you so much, Dr. Loveleen. Can we take some questions from our participants? Dr. Loveleen?
Yeah, sure, ma'am.
Someone is asking here, do you provide residential facilities?
Yes, ma'am. We have a residential facility. If anyone want to check it out, the residential facility. If anyone wants to check it out, the residential facility, then go to our website over here. Then admissions, go to the admissions, and then we have the residential facility over. And if anyone wants to see the video for our what feature what you can say facilities we provide in the residential facility, then also we have put the video over there, and you can watch this residential facility about the residential facility. So you can see 25,000 plus residential students we have. And we have uni hospital, we have indoor stadium, so many facilities we have, multi-stored library, we have kiosk, we have, so all the basic needs you can fulfill over here in the LPU. I hope I have answered the query.
Yes, Dr. Loveleen, thank you so much. I hope the participant got the answer from our expert. As we come to the end to this webinar, I want to express my deepest gratitude to our experts for sharing their valuable insights and expertise with us. Your presence, enthusiasm, and active participation have made this experience truly special. Hopefully, the attendees found this webinar to be valuable and will be able to utilize the information for better decision making regarding their admissions. If anyone wants to access this webinar, they can visit our website, that is lpu.in, or can be accessed on YouTube also. Stay connected with us for future webinars. Until we meet again, with the permission of my seniors, I would be signing off this webinar. Take care and goodbye. Have a nice day.
Thank you, ma'am.